the minimum edit distance problem. According to this problem, for two given string S1 and S2, we need to find out the minimum operations required in order to convert S1 into S2. To understand the problem in a better way, let's take an example of two strings. S1 is hello and S2 is help. So we have the given string S1. We need to convert this S1 into S2. That is, hello should be converted into help. We are supposed to find out how many operations are required in order to convert hello into help. That is the problem. However, in the process of converting S1 into S2, we have a specific set of operations only. These operations are insert a character into S1, remove a character from S1, or replace a character in S1. So these are three operations that we can perform on S1. With the help of that three operations, we need to convert S1 into S2, that is hello into help. So what we are supposed to do for that, the given string S1 is hello. First of all, to convert it into help, we need to remove this character O. Then we need to replace this L with P. Then that will become HELP, that is S1 is now converted to S2. So O to be removed, that is one operation, and rightmost L to be replaced by P. So that is another operation. Altogether, it needs two operations. This is the problem, and we will use dynamic programming to solve this problem. We are taking an example where S1 is equals to A, B, C, D, E, F, and S2 is equals to A, Z, C, D, E. We'll be using the memoization technique in dynamic programming. So for that, we have created a table with number of columns equals to the size of S2 or length of S2, which is equals to 5, and number of rows is equals to length of S1, which is 6. So we have created a 5 by 6 or 6 by 5. We have created a 6 by 5 matrix, and as a process of the algorithm, we will fill this table with numbers. First, let's see how we will fill these cells. Let's consider this cell as an example. This cell indicates that S1 is equals to ABC. ABC. S1 is equals to ABC, ABC, and S2 is equals to AZC, AZC, AZC. Now, in order to convert ABC into AZC, how many operations are required? That number we will write here. If I look at this two strings, then we can see we need to replace this B with Z. That means one operation is required. One operation is required. So that's why we'll put 1 here. Now we will fill the table. So let's start from the first cell here, and we will first fill this row, then we will fill this column, and these values are the base conditions for the algorithm. Let's fill this first cell. This cell says that S1 is S1 is equals to null and S2 is also equal to null. How many operations are required? Obviously, the number of operations required is 0. That's why we will put 0 here. We'll put 0 here. This cell says that the existing string is null, s1 is equals to null, and we want to convert it to s2 is equals to a. So one operation is required, so we will write one here. Here we need two operations, here three operations, four operations, and five operations. We have previously seen that to replace a string from s1 to s2, we have three operations. One is insert operation, insert. Second one is remove operation, and third one is replace operation. Here in these cells, what we have seen that we are inserting one character in the null string to get the string A. We are inserting two characters in the null string in order to get A, Z, so on, so forth. And that insert operation in this case is indicated by a horizontal arrow. Remove operation is given by a downward vertical arrow, and replace operation is given as a slanted arrow in the operation. So here, since we have inserted one character, we will mark this operation as insert operation. We will mark all these operations, like here we are inserting, we are performing insert operation, we are performing insert operation, here also we are performing insert operation. Now we will fill this column, first column. So here it means that S1 is equals to A and we want to convert it S2 is equals to null. So how many operations are required? We need a single operation to remove that element. So in order to remove, the remove operation is indicated by this arrow. So we will write down this arrow here in this place. Similarly, in the next one, this cell, we need two operations. Here we need three operations. Here we need four operations. Here we need five and six. So this completes the base condition for the dynamic programming for finding the number of operations required to replace from S1 to S2. Once we have the base cases available, we will try to fill all other cells in the table, all other cells. Here at this point of time, we will apply certain formula. We'll consider this one as this side as C and this side as R, this side as R. That is, this cell indicates R is equals to A and C is equals to C, row A and column C. In every cell, what we will do, we'll check if R is equals to C. If R and C are same, that means, for example, we can consider the example, this one, this example. Here, row is C and column is also C. That means R is equals to C. Otherwise, in this case, or let's say, not this case, let's say here, R is equals to C and C is equals to E. That means row is not equals to column. If R is equals to C, we will fill the value from the diagonal cell. That is, in this case, since in this cell, both row is equals to A and column is also equals to A, both are same. That is why whatever the value in this cell, we will copy into this cell. It is 0 here. So we will put 0 here. And the operation is known as replace. What does this mean? It means that in order to get a string A from A, we need not have to perform any operation. Zero operations are required. Otherwise, if R is not equals to C, then we will take the minimum of its surrounding cells. For example, if I take this cell, this cell. To fill this cell, what we will do, we'll take the minimum value of this cell and this cell, and add one and store it here, right? Again, if I take the value from this cell, then we will consider it as an insert, as an remove operation. If I take the value from this cell, we will consider it as an insert operation. And if I take the value as from this cell, then we consider this as a replace operation. However, this concept of arrows is not applicable for the cells where C equals to R. That is, this cell, it is not applicable. The mark in this cell indicates that we have taken the value from this cell. With that, let me fill this table. We will take the first cell here, this cell. In order to fill this cell, since row is equals to row A, column is also A, row is equals to column, that's why we will put the value from the diagonal cell to this cell. For this cell, column is not equals to the row, so we will take the minimum of this value, and this value, and we will add 1. So it becomes 1, and we take the value from nearby node, nearby cell, and that's why it is considered as an insert operation. Similarly, for this cell, A is not equals to C, so we'll take the minimum is 1, and we will add 1, and it is 2, and it is coming from, it's an insert operation. Here also it becomes 3 and insert operation. Here it becomes 4, another insert operation. Now let me see whether with this operation this is correct or not. Let's say this cell. In this cell, S1 is A. S1, at this point, S1 is A, S2 is A, Z, C, D, A, Z, C, and D. Our objective is to reach A, Z, C, D from A. We need to add 3 characters, so that's why 3 operations are required. 3 operations are required. And apart from that, it shows that this operation is an insert operation. That's why we are having 3 insert operations in order to replace the string from A to A, Z, C, D, and that is correct. So similarly, we'll fill rest of the cells very quickly. Finally, at the end of the execution of the algorithm, we get a value in the last cell of the table. So this cell indicates that in order to convert a string from A, B, C, D, E, F to A, Z, C, D, E, we need two operations. Two operations. This table also says what are the various operations that we need to perform. For example, if I consider this one as 2, and we can see here this 2 is coming from the cell above it, and this is an remove operation. So it means that the value f, character f to be removed. Then we'll go to the upper cell. We can see here this E and this column and rows are same. When column row R is equals to C, there is no operation. So we'll go, this one is coming from this diagonal cell, we'll go here. Here also we can see D is row is equals to column. That's why it is there is no operation performed. So this one came from its diagonal element. We will go there and we can see here C is equals to C. No operations required. This value coming from this cell, diagonal cell. We go here and we can check B and Z are not same. That means at this cell it is 1 and it is coming from this 1, and the value of R and value of C is not same, and this operation indicates that it is a replace operation. So what value we are replacing? We are replacing value B. We are replacing value B with B replaced with Z. So exactly that is happening here. B is replaced with Z, F is removed, and we reach the string S2.